Hello, this is Irv Shapiro of the Dr. Vax channel. And it's been a couple weeks since I last published a video, which is unusually long for me, but I was preparing for a new series. Last year, many of the videos I published were about utilizing tools, 3D printing, woodworking equipment, a little bit of electronics, and I emphasized reviews of new 3D printers, discussions of slicers and filament. This year, in addition to all of that, I'm going to also start helping people understand how to design things from scratch. Instead of just downloading models from Thingiverse or other online sites and printing them, or maybe modifying them slightly, I want to teach people about tools they can use without a lot of training, but with a bit of investment in time to create their own models. That opens up the possibilities to using 3D printing and woodworking and other technologies, maker skills to fix things around your home, to create one-of-a-kind items, unique, special items. So stay tuned and let's learn something together. The tools I'm going to cover today are all completely free. And while there are more sophisticated tools available for professionals, for businesses, for commercial use, these tools are accessible by everyone. Now, I'm sure if there are viewers of this channel who are professional engineers using a high-end computer-aided design tool, you may find some of these tools slightly limited. But I selected them because they're easy to use, they're free, and by combining them together in different ways, I think for most hobbyist, home-based users, even small businesses periodically using 3D printing or other manufacturing environments, these tools will really get the job done. So let's get started by talking about computer-aided design. That's where you draw a picture, two-dimensional or three-dimensional, on a computer, and then you save it in a format that you can use, in our case, with an automated manufacturing system. Let's go to the slide. I divide this world into three categories. Now, I'm a software engineer by training with a computer science degree from the days of the dinosaurs. I'm not a mechanical engineer. I'm not an environmental engineer. I'm not an electrical engineer. I've really never used CAD tools professionally. So this is just an easy way for me to understand these types of tools. So the first category I'll refer to as object primitive modeling. The next category, parametric modeling. And the third category, mesh modeling or sculpting. I really spend very little time with the third category. I'll explain why in a minute. In object primitive modeling, you basically start with predefined shapes, cubes, pyramids, spheres, and by combining those shapes together on your screen, you build objects. The advantage of object primitive modeling, if we look at the slide, is it's very easy to use for simple models, but maybe not suited for complex models. While it's easy to use, it's difficult to reproduce a model because you're more or less stacking blocks. Think about building something with Lego. And then if you want to change something on the bottom layer, it's hard to do that. Or it's hard to tell someone what all the steps were you took to build what you built with blocks. It's very good for fast prototypes. It's very, very easy to use. In fact, it's taught in a lot of schools. Specifically, we're going to look at Tinkercad as an example of this technology. The next category, parametric modeling. In traditional parametric modeling, you start with a two-dimensional sketch. Then you extrude it, or you pad it, you manipulate it, you transform it into a three-dimensional object. You still combine objects together by using Boolean logic or by cutting one object out of another object. But because you've started with a sketch defined by a set of parameters, those steps for transforming from a flat object to a three-dimensional object are saved in the program. That's what makes it parametric. You can go back to an earlier step, and I'll show you an example of this. You can change one of those parameters. In essence, the computer program will rerun all the steps and rebuild your model. So the act of creating a three-dimensional model creates a series of steps that you can reproduce at any time because you save those series of steps. These tools tend to be difficult to learn. You have to make a little bit of an investment. I would say that to begin with parametric modeling is a 1 to 2 day investment of time. To begin with object primitive modeling is probably a couple hours of time. But a good parametric modeling tool can be used to build very complex, sophisticated objects. Let's go to the third category. This third category I call mesh modeling or sculpting. And you can think of it as if you had a block of clay that you were going to manipulate with your thumbs and tools and carve and sculpt out of it. I do find this third approach requires more artistic skills. I don't have those artistic skills. I have pretty good engineering skills, but not great artistic skills. So I'm not as comfortable with this approach. However, some of the tools in this category, in addition to the sculpting capabilities, have abilities for manipulating meshes. Now, when you start with a 3D modeling tool in the parametric category or the object manipulation category, internally it's saved as a set of mathematical equations. But then when you save it as an STL file, it's creating a mesh. Basically, it's representing your object with a series of triangles or rectangles, geometric objects that are combined together. That mesh is then what we use with a slicer, where it slices that mesh into layers to 3D print it. If you want to manipulate the mesh directly, you need a tool that knows how to do that. In this category, we're going to look at Meshmixer as an example of that type of tool. Now, let's go through and talk for a moment about 4 tools I'm going to cover today very quickly. The first tool is Tinkercad. Really easy to use. Everyone can learn how to use Tinkercad. It is an object modeling tool. It is for basic or simpler models. It can do very basic mesh editing in that you can import a mesh, you can import an STL file, and then use it to manipulate it a bit. It does have interesting SVG support. I'll explain why that's important a little bit later. It has very little, almost no image manipulation support, so you can't take a photograph, a JPEG as an example, and really use it effectively with Tinkercad. And you can get relatively precise models, but it's a little bit kludgy to do that because you're working with the manipulation of 3D objects. Now the next program here is a program many people may not have heard of. It's called FreeCAD. FreeCAD is an open source, completely free, computer-aided design product with complete parametric modeling. You start by drawing a sketch. I'll show you an example. You extrude or pad that sketch to make it a three-dimensional object. You then combine it with other sketches that can be used to extrude or cut objects out of your model. It is a very, very impressive piece of free software, and it competes at the low end with commercial tools such as Fusion 360. Fusion 360 is a wonderful tool, but it's basically about $500 a year. Yes, you can use it for a year free as a hobbyist or a small business. Yes, maybe you can get an educational license, but their licensing model tends to be in flux. And so if I'm going to spend days learning a parametric modeling tool, I want it to be something I don't have to worry about paying $500 a year for if I'm only going to use it a few times a year in the future. So FreeCAD is very interesting, and I'm going to show you that today. MatterControl is sort of a hybrid tool. You start with three-dimensional objects, but it keeps a history of how you manipulate each object. So in that sense, it's parametric. But we're going to show you MatterControl today because of its ability to take JPEG images and turn them into 3D objects. Really magical. I'm going to show you that today. And then finally, I'm going to talk just a little bit about Meshmixer because it's a free tool that you can use to manipulate your STL files. Now, Meshmixer and Tinkercad, along with Fusion 360 that we're not talking about today, are all produced by Autodesk. Autodesk is one of the leading providers of CAD, computer-aided design, and CAM, computer-aided manufacturing technologies. Okay, let's get started with some quick demos. The first tool I'm going to demonstrate is Tinkercad. Anyone can go to tinkercad.com, sign up for a completely free account. And I'm going to create a new design. And this is not a tutorial on Tinkercad. I'll link some other tutorials I have on Tinkercad, but I just want to show you the idea of object modeling, and then I'll show you the idea of parametric modeling, hybrid modeling with MatterControl, and then we'll talk about mesh modeling a little bit. So we're going to create a new design, and we do that by taking an object and dragging it into the work plane. We can then resize that object either with our mouse or by manipulating these numbers over here. Now, if I want to put a hole into this rectangle, I drag another object that's defined as a hole. So you can see for any object, you can define it as a solid or a hole. I drag that into the location I'm looking for of my current object. Let's make this a little bit taller so we can see it a little more easily. And then we'll push it down. Now I can select these two objects, group them, and I now have a hole in my rectangle. I could also take, let's ungroup these, select these objects again, and whoops, let's make sure I get them both. And now I'm going to align them and center them both. So I have that hole centered in the middle of my rectangle. But what happens if I take and I ungroup these, I select my rectangle, and I change the size of the rectangle? Well, because this is not a parametric modeling tool, that circle did not stay aligned. I'd have to go back, select both objects, align it again. And then I could group it, and I'd have the circle in the middle. What if I wanted to change the size of just that circle? Well, when they're grouped together, if I manipulate it, everything changes. So it's really easy to use this, and it wouldn't be hard to go back and change. In this case, we have two objects. What if you've put together 15 objects to make a drawing, and then you want to manipulate it? A little bit harder. So let's look at an alternative. Let's look at parametric modeling. Okay, when we get started with FreeCAD, it will come up to a start page that has a series of references for various type of help that we can use. FreeCAD is a parametric modeling program, and it is a bit tricky to learn. If you really want to learn it, you're going to spend a couple days before you get comfortable with doing your first real models that you're probably going to want to 3D print. In our particular case, we're going to very quickly model something. So we're going to create a new document. I'm going to close my start page. And we're going to start on the Part Design Workbench. Now, the Part Design Workbench, a workbench is a collection of tools for a particular style of computer-aided design or computer-aided modeling. This is for producing three-dimensional objects parametrically from sketches. So that I have a better view of what's going on here, I'm going to turn on my Convo view here on the side, and that will show me what I've modeled and also recommended tasks. Let's create a body and create a sketch. And we're going to put this on the XY plane. Click OK. And now we can go ahead and draw a rectangle on our screen. Now, this rectangle right now is not really locked down in any way. There are no dimensions or anything. But at the very minimum, I want to align it to our axes so I have a natural center position. So in order to align this to the axis, I'm going to click on this point up here, Command click on this point up here, and then click on this axis, and I'm going to create a symmetric relationship. Now, if I move this, it's going to move symmetrically aligned around that Y or vertical axis. Okay, now in order to lock down this second dimension, I'm going to align that symmetrically to this axis. So I'm going to take this point here. I'm going to take this point here. Let's make sure we get them selected. This axis here, and create a symmetric relationship. Now, this rectangle is going to stay symmetric to the center. That means that things I want to align to the center, I can align naturally to that center position. I'm going to close this now. If we rotate, we'll see we have a flat plane. I'm going to select that one more time, and I'm going to extrude it or pad it. And now you can see that we have a very nice box or a rectangle here. So let's continue with this. Let's select a surface on that box or rectangle and put another sketch on it. In this case, I'm going to take a hexagon and I'm going to put it centered around the middle of this object. And let's go ahead and say that this side of the hexagon must be horizontal. Okay. Now I can make it a little bit bigger. So now that hexagon is locked to the center of this box. It's centered on that center point. The box is symmetric to that center. So I can close this. I'm going to select, whoops. Let me take and hide this so I can select the hexagon because it was really underneath. It was on the bottom because I put it on the same XY plane. And I'm going to pad or cut a hole with it. So you can see we now have a hole cut in our object. And I could say it's through all, or I could give it a depth. Doesn't really matter. Okay, so we have this very nice object with a hexagon in the middle. So far, similar to Tinkercad. But what if I change the dimensions of this original sketch? Let's say I make this much smaller. I close this, and it automatically updated this object. So you can see I have the hole hasn't changed. It's still centered though, and it's still in the same position. Once again, I could change this. I could make this much bigger. Close it, and now it's centered. So that's the magic of parametric modeling. Now, let's take a look at another tool. Now, this tool, and I've done the steps of dragging a rectangle in, dragging a cylinder in, and combining them together with what's called a subtract operation in this tool. And this is pseudo-parametric because you start with predefined objects. You don't start with a sketch with MatterControl. But I can go to this cube here and I can change the dimensions, and you can see the cylinder stays centered. Let me even change it more radically so you can see that. So this has the ability to manipulate parametric objects just as you would in a parametric modeling system, but you start with predefined objects. By the way, in FreeCAD, there's a way to do that also. It's called the part workbench instead of the part design workbench, and it works similar to this. Now, what's really powerful about MatterControl, though, is not its generic CAD capabilities. I think Tinkercad's easier to use, and FreeCAD is more sophisticated. What's really powerful is it has this ability to take a JPEG file, just a regular picture, and convert it automatically into a three-dimensional object. Isn't that magical? And then you can use that in conjunction with other objects that you're going to manipulate. Now let's push it down a little bit. You can see it comes out the bottom. There we go. Now let's select these two items, and we're going to do a subtract. And we're going to say we want to subtract the cylinder. Update. There we go. And now we have a hole in the top of our angel. So MatterControl is not as polished as Tinkercad and not as sophisticated as FreeCAD, but this ability to start with a JPEG image is magical. Okay, let's go back to our slides now and talk about very quickly two other tools, Blender and Meshmixer. Many people love Blender. It's an artistic tool in the sculpting domain. I personally, I'm not an artist. I find it very hard to use. But for many people, and I needed to mention it today because there are a lot of fans out there, Meshmixer is very interesting to me because while it also can be used as an artistic tool, in addition, I can use it to slice apart models. So if I have a model that's too big to print on my printer and I wanted a top half and a bottom half, Meshmixer will allow me to manipulate the mesh. I can sculpt it, but I can also slice it easily into parts so I can print one part, then the second part, then glue them together. Folks, at this point, let's summarize what we've learned today. Use computer-aided design programs to create your models. They can be very simple like Tinkercad, and I think that's the best place for everyone to start because it teaches you the idea of starting with objects and combining them together. Because even in a parametric modeling system, you're going to have to combine objects together. Once again, if you want to start with an image and create a three-dimensional model, I'd recommend MatterControl. If you want to fix STL files or slice them into pieces so you can print big models on a smaller printer, I'd recommend Meshmixer. And to end, there is a really remarkable tool that combines many of these capabilities. It's called Fusion 360, but I think it's a bit pricey for a lot of people doing this casually at home or once in a while. Folks, if you learned something today about object manipulation, about parametric modeling, about mesh manipulation, give me a thumbs up, recommend this video, share it with everyone you want. You can take the URL and share it anywhere you'd like. Thanks so much, and let's continue to learn things together.